Okay, today we're going to solve more trig equations, but now we're going to use factoring. Yesterday we didn't factor anything. Today we're going to factor. So let's take, and we've got to remember, check on the calculator, QRS, all that good stuff. So number one says find the exact solution from 0 to 2 pi. So what that means is we're going to have to convert degree answers to radians. All right, so here we go. 2 sine squared theta minus equals 1. You can use 2x squared equals 1. So what I would do is I would divide by 2, and so I'd get x squared equals 1/2. And then remember, to get the x by itself, we'd have to square root both sides. Now when you square root both sides, you have to do plus and minus. So you get x equals plus and minus. This becomes radical 1 over radical 2, which is really just 1 over radical 2. And if you rationalize that, you really have x is equal to plus and minus radical 2 over 2. All right, so the same thing would happen with the sine squared. You'd end up with sine theta equals plus or minus radical 2 over 2. So now what this presents us with is the situation where we have to consider, where sine theta equals radical 2 over 2 and where sine theta equals negative radical 2 over 2. So I'm looking for QRS, whereas sine positive would be quadrants 1 and 2. Reference angle 45 from the chart. Just reminding us we're positive here. If sine theta is equal to negative radical 2 over 2, that's quadrants 3 and 4. And still positive reference angle of 45. It's just going to affect the quadrants, that negative. So the measure of angle theta would be 45, and then 180 minus 45, which would be 135. And then I'm going to keep going here because then we're in quadrant 3, which would be 180 plus 45, which is 225. And then in quadrant 4, it'd be 360 minus 45, which is 315. So now we need to convert all of those to radians. So 45 degrees is pi over 4 radians. 135 over to the side, we're doing times pi over 180. All right, and that's going to be 3/4. This simplifies to 3 and 4, so that's 3 pi over 4 radians. And then 225, another way to look at this is, if you took 45 times 3, you'd get 135, so that's how we got 3 pi over 4. If you took 45 times 5, you'd get 225, so this one would be 5 pi over 4. And if you took 45 times 7, it'd give you 315, so this one is 7 pi over 4. Or you can go to the side again and do 225 times pi over 180, and you get 5 pi over 4. This cancels to 4 and to 5. All right, so you could do those that way. And so that's the measure of theta in radians, exactly. All right, next one. So for this one, you could be thinking tan, cosine minus cosine could be like xy minus y. So it's GCF factoring, so if we took a y out, we'd be left with radical 3x minus 1 equals 0. And then you set up your t, and you'd have y is equal to 0, and radical 3x minus 1 is equal to 0. Add 1 to both sides, and you get radical 3x is equal to 1. And then divide by radical 3. So x is equal to rationalized radical 3 over 3. So then now you got to go back and say, okay, tan was the x, and cosine was y. So when we say y equals 0, that would be cosine of theta equals 0. And when we say x is tan, so we have x equals radical 3 over 3, that would be tan theta
Shanley, please come to the main office. Alex Shanley, please come to the main office.
equals radical 3 over 3. So now we're ready to solve this. So tan theta equals radical 3 over 3 is positive. So quadrant 1 and 3, because that's where tan is positive. The reference angle is 30 degrees from our memorized chart. Sign positive, positive, just reminding us that 1 and 3 are correct. So then these are 30 degrees. So let's see, 30 degrees, and so the measure of angle theta is equal to 30, and in quadrant 3 it'd be 180 plus 30, which is 210, and then the measure of angle theta is equal to pi over 6 radians, and then again you could go to the side and figure out 210 if you need to times pi over 180, and we get 7 pi over 3, or 7 pi over, I'm dividing them both by 3, so 6. So 7 pi over 6. Another way to look at it is to say 30 times 7 is equal to 210, so I would take 7 of the pi over 6's, so 7 pi over 6. All right, cosine theta equals 0. So remember, these are the quadrantals. So I'm looking for where are the x coordinates 0. So they should be 0 here at 90 and at, there's 90, and at 270. I get 0, negative 1, and I get 0, 1. So the cosine of 90 degrees equals 0, and the cosine of 270 equals 0. So that would tell me that theta would be 90 and 270, or pi over 2 and 3 pi over 2. But if you substitute pi over 2 back into the original equation, so if you do a little check, and you do radical 3 times the tan of 90, cosine 90 minus cos 90 equals 0, the tan of 90 is undefined. So we need to reject that. That's rejected, and the tan of 270 is also undefined. So that one needs to get rejected. So we only have 2 answers that work. So this one might be a good one to check on your calculator. Okay, so we'd go back in here and we'd take that left side, which would be the square root of 3, tan theta. So we're going to do tan x and cos x minus cos x. And then in y2, I'm going to just put 0. Okay, so I'm going to keep it in degrees. I think it's already there. Nope. That's right, I changed it. Let me check my window is in degrees, though. I'm solving these from 0 to 2 pi, so 0 to 360. Let's change back that y max to 4. Okay, and I'm just looking for where it intersects the x-axis, which is the 0 line. And if you notice, from 0 to 360, it only hits in 2 places. And I'm going by 30s, so it would be 30, 60, 90, 180, 120, 150, 180. So, 210 would be this one. The other one back there was 180. So, 30 and 210, second trace, if we do intersect, enter, enter, enter. It's going to take me to the 210 one. You can see the first one's 30. So it was correct for us to reject the 90 and 270. All right, next one. I'm going to be using 8x squared minus 6x minus 5 equals 0. So to factor that, I am going to try 4x and 2x. And then I have choices of 1 and 5 or 5 and 1. So I'm thinking if I put the 5 on the outer side, that's going to give me 20, really big. So I'm going to try the 5 on the inside. That gives me 10 with the 2. And then if I put a 1 on the outside, that gives me 4. 10 and 4 do equal 6. I need it to be negative 6, so I want it to be negative 10, positive 4. So those are my factors. And then if I solve those, I get x equals 5/4 and x equals negative 1/2. So now I need to go back and say, all right, sine theta equals 5/4 and sine theta equals negative 1/2. That's what I got over there. You can't just stop at x equals. You're trying to solve these for theta. So now I'm going to, again, set up QRS. So quadrants 1 and 2 is where 5/4 is positive, so I'm looking for where sine is positive. So I need to do second sine. I'm in degree mode. So second sine, 5 divided by 4. Ooh, it says error quit, domain. Okay, well, if you think about it, if we graph the sine curve, okay, so we will do what they say there, quit. All right, clear this out. If you graph the sine curve, look at the range. It goes from negative 1 to 1. Now look at my question. I'm saying where is sine theta equal to 1 and 1/4? Nowhere, because it doesn't go above 1. So this part has no solution, okay? So we just reject this whole side, and we only consider the right-hand side. Sine theta equals negative 1/2. So QRS, oops, I'm trying to spell reject here, not working out so well. All right, so then quadrants, where is sine negative? Because you see a negative 1/2. Quadrants 3 and 4, reference angle 30. Okay, so for this one, quadrant 3, I'm going to do the measure of angle theta is equal to, it's 180 plus 30, 210. Quadrant 4, I'm doing 360 minus 30, which is 330. So those should be the two solutions. I just need to put them in radians. If I look at the previous problem, 210 was 7 pi over 6 radians. And then 330, I have to do 330 times pi over 180. So 33 divided by 18, so the zeros go. 18 divided by 3 is 6. 33 divided by 3 is 11. So it looks like I have 11 pi over 6 radians. So that's the measure of angle theta in radians. Okay? If we go quickly to the calculator and we check that, we would have 8 sine. Now to do sine squared x, we have to do sine x squared like that, minus 6 sine x minus 5, and we want the equals 0. So I think we should be good. Let's try graph. We're looking where it intersects the x-axis. There's one of them. And one more. Yep. So there we go. So if we do second trace intersect, enter, 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 there's one of our answers, 210. And I'm guaranteeing you the other one going to have it go along the x-axis, so I had to use the down arrow. Okay, so enter, 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 and that one is 330, which is what we got. And we put them in radians. All right, next page. All right, find to the nearest tenth of a degree. Okay, so I'm going to just keep the cosine squared in there. If you want, you can solve it as x squared on the side. I would have 25 cosine squared theta equals 4 if I add 4 to both sides. And then if I divide both sides by 25, I get cosine squared theta equals 4 over 25. So to solve that, I am going to take the square root of both sides. And when I do that, I have to do plus and minus. So I get cosine theta is equal to plus or minus 2 over 5. So now I have cosine theta is equal to positive 2/5, and I have cosine theta is equal to negative 2/5. So I've got 4 possible answers here. So I'm going to go Q, R, S, so 1 and 4, and then 2 and 3 for where cosine's negative. So to find that reference angle, I'm going to go back and do second cosine 2 over 5, keeping it positive. So second cosine 2 over 5. So 66.42 for both. Okay, the negative just is talking to us about the quadrant we're in. So to the nearest tenth of a degree, the measure of angle theta would be 66.4 degrees. For quadrant 4, it would be 360 minus 66.4 degrees, which is 293.6. For quadrant 2, I'm doing 180 minus 66.4, which is going to be 113.6. And for quadrant 3, I'm doing 180 plus 66.4, which is 246.4. So those are those answers. Okay, next one, secant squared. All right, so I'm going to think of this as x squared minus 7x plus 12, and I'm going to factor. And I'd get secant theta, the way to have x and x. And I'm looking for two numbers that multiply to 12 that add to negative 7. So let's see, that would be negative 4 and negative 3. So I would have secant theta minus 4 equals 0, and secant theta minus 3 equals 0, which gives me secant theta is equal to 3, and secant theta is equal to 4. Now, remember, secant theta is equal to 1 over cos. So then I'm going to flip this around and say, well, cosine theta is equal to 1 over 4. And cosine theta is equal to 1 over 3. So I'm going to now set up QRS. So I'm in quadrants 1 and 4. And again, QRS. I'm in quadrants 1 and 4. It's just going to be different reference angles. So cosine 1/4. So I'm going to do second cos 1 divided by 4. All right. So that's going to be the answer for quadrant 1. For quadrant 4, I'm going to do 360 minus second ants. So I have 75. This was supposed to be to the nearest tenth. So 75.5 and 284.5. 75.5 and 284.5. So the measure of angle theta equals, so far that. Then I'm going to do second cos 1 divided by 3. And then I'm going to again do 360 minus that answer. and I get A289.47, so I've got 70.5 and 289.5. 70.5 and 289.5. Okay? And those are those answers. Okay, last one. Find to the nearest hundredth of a radian. So I'm going to go put myself in radian mode, okay, to solve this one. So let's factor first. So I'm going to do 3 sine theta and sine theta. And I'm going to do plus 2 and plus 1 this way because 6 plus 1, check the outers and the inners. Got to know how to factor. 6 plus 1 is 7. So then it looks like 3 sine theta plus 1 equals 0. And sine theta plus 2 equals 0. So I have sine theta equals negative 2. And I have sine theta equals negative 1/3. Now remember on the previous one, when we had a value that was not between negative 1 and 1, it's going to be rejected. So this one is going to be rejected. Okay? Doesn't work. So all I have to do is this last one. So where is sine negative? Quadrants 3 and 4. Lovely track team. So I'm going to do second sine 1 divided by 3, and I have 19.47. Now I need to go back and change that mode though. I want to be in radians. Okay, so I'm going to put myself in radians, and then I'm going to go back here and try this again. So I'm going to go up to that and get it again now in radians. It's 0.3398. Oops, I'm looking for negative. I'm good. All right, so in quadrant 3, the measure of angle theta, I'm going to do pi plus 0.3398, that reference angle. And in quadrant 4, I'm going to do 2 pi minus 0.3398, which is equivalent to 180 plus a degree measure of a reference angle and 360. So pi plus, I'm going to go back here. I've already got it there, so plus pi, so I get 3.48. They wanted it to the nearest hundredth. And then I'm going to go back to my calculator, and I need to do, I'm going to subtract out the pi to get that back. So I'm going to do that minus pi, and I'm back to my reference angle if I just take the pi out that I added in. And then I'm going to do 2 pi minus that reference angle. So that's 5.94. And again, you could check that on the calculator, see if they intersect. I'm running over. I want it to be 20 minutes. Sorry about that, but have a good night.